Geico's motorcycle expertise means I'm covered by people who know bikes like I do. I'm happy as a clam.
Disclaimer, no conclusive scientific research has shown clams can experience happiness.
I just meant that I feel really good about my coverage.
I mean, even if you took the clam out for the best day ever, visiting the zoo, taking a scenic ride, knowing you're insured by specialists, and sharing a strawberry ice cream cone together, the clam would not feel happy, and your strawberry cone would taste sort of clammy.
Ew.
Geico's motorcycle specialists who know bikes like you do assume no liability for clammy ice cream cones. Geico. Expertise for your motorcycle.
Taxes was taxing. Now taxes is relaxing when you file for free.
I can file for free? TurboTax Free Edition. Roughly 37% of filers qualify. Simple Form 1040 returns only. See if you qualify at turbotax.com/free. I can file for free.
Now this is taxes. File for free with TurboTax Free Edition and get your maximum refund. No schedules except for earned income tax credit, child tax credit, and student loan interest. See if you qualify at turbotax.com/free.
Hello, and welcome to Astronomy Daily. I'm your host, Anna, and we have a big lineup of space discoveries and breakthroughs to share with you today. We'll journey beyond Neptune, where the James Webb Space Telescope has made remarkable findings about mysterious objects in our solar system's outer reaches. We'll hear from astronauts aboard the International Space Station who want to set the record straight about their extended mission. We'll also explore a fascinating new theory that challenges everything we thought we knew about the emergence of intelligent life in the universe. Plus, we'll examine groundbreaking analysis from asteroid Bennu samples, peek into Earth's surprisingly dynamic inner core, and look at innovative new technology for exploring low-gravity environments. Strap in for an exciting journey through the latest developments in space science and exploration. Let's get started. NASA's James Webb Space Telescope has revolutionized our understanding of Trans Neptunian objects, those mysterious celestial bodies orbiting beyond Neptune's path. In an unprecedented study, Webb has provided the first detailed look at the composition of these distant objects, revealing surprising new insights about our solar system's formation. Trans Neptunian objects, or TNOs, include everything from dwarf planets like Pluto and Eris to smaller bodies like Arrokoth. While scientists have known about these objects since Pluto's discovery in 1930, we've never been able to study their composition in such detail until now. Using Webb's near-infrared spectrograph, scientists have analyzed over 75 TNOs in the first 2 years of the telescope's operation. What they found was completely unexpected. These objects can be categorized into 3 distinct spectral classes based on their surface composition. The first group, dubbed bowl type, shows strong signatures of water ice and some carbon dioxide, along with silicate-rich dust. The second classification, called double dip, reveals complex organic molecules mixed with carbon dioxide and carbon monoxide ices. The third group, known as cliff type, contains the most complex organic materials of all, along with compounds like methanol. This classification system isn't just about categorizing space rocks. It's helping scientists piece together the story of our solar system's early days. The theory is that these different compositions reflect where these objects originally formed, with bowl types developing closer to the sun where temperatures were higher, while double dips and cliffs formed in the colder outer regions. Particularly intriguing is that all objects found in undisturbed cold classical orbits belong to the cliff category. This suggests these objects have remained largely unchanged since the solar system's formation, making them invaluable time capsules of our cosmic history. Webb continues to study these fascinating objects, with new observations planned to examine extreme TNOs that venture far into interstellar space. These ongoing studies promise to reveal even more about the materials and conditions that shaped our solar system billions of years ago. Next up, let's pay a visit to the International Space Station for an update from our 2 favorite astronauts. In recent months, there's been quite a bit of attention on NASA astronauts Suni Williams and Butch Wilmore, who found themselves on an unexpectedly extended stay aboard the International Space Station. While some media outlets have painted this as a story of stranded astronauts, the reality is quite different from these dramatic headlines. The duo originally launched on Boeing's Starliner spacecraft for what was planned as a 10-day mission. However, when Starliner experienced thruster issues during docking maneuvers, NASA made the decision to adjust their plans. Rather than rushing a solution, they've incorporated Williams and Wilmore into the ongoing crew rotation schedule, specifically as part of SpaceX's Crew 9 mission. Both astronauts have been quick to set the record straight about their situation. As Wilmore recently explained to CNN's Anderson Cooper, "We don't feel abandoned. We don't feel stuck. We don't feel stranded." In fact, he emphasized that mission extensions are simply part of the job in human spaceflight, where being prepared for contingencies is fundamental to their training. What's particularly noteworthy is that both astronauts have maintained their regular duties throughout this extended stay. Williams has even managed to break the record for most cumulative spacewalking time by a woman during this period. They've been fully integrated into the station's operations with access to all necessary supplies and equipment. The situation gained additional attention when it became part of a political discussion. But the astronauts have remained focused on their mission. They're now scheduled to return to Earth in March, following the arrival of Crew 10. As Wilmore puts it, they're not stranded, they're prepared and committed, which is exactly what you'd expect from seasoned space professionals. Both Williams and Wilmore, veterans of previous long-duration space missions, have expressed their continued enjoyment of life in orbit. As Williams noted, "It's just amazing how quickly you readapt to life in space." She even admitted that when the time comes to return home, they'll likely feel a touch of sadness at leaving their weightless environment behind. And just a little side note, how famous has that hair become? All right, let's get back on track. New research from Penn State is challenging our long-held assumptions about the likelihood of intelligent life in the universe. For decades, scientists believed that humanity's emergence was an incredibly rare cosmic accident, but this fresh perspective suggests something quite different. The traditional view, known as the hard steps theory, argued that the evolution of intelligent life required an unlikely series of fortunate events. However, this new study proposes that intelligence might be more of an inevitable outcome of planetary evolution, both on Earth and potentially on other worlds. The researchers explain that Earth's environment wasn't always hospitable to complex life forms. Instead, it evolved through distinct phases, creating what they call windows of habitability. For instance, the development of complex animal life required specific oxygen levels in the atmosphere. This didn't happen by chance. It was a natural consequence of photosynthesizing microbes gradually changing Earth's atmosphere over time. What's particularly intriguing is their suggestion that humans didn't evolve early or late in Earth's history, but right on time, when conditions were finally suitable. As Dan Mills, one of the study's authors, explains, it may simply be a matter of time before other planets achieve similar conditions, with some potentially reaching these milestones faster or slower than Earth did. The team, combining expertise from both astrophysics and geobiology, argues that we should view evolution through the lens of geological timescales rather than comparing it to the sun's lifespan. This shift in perspective suggests that the development of intelligence might be more of a predictable process, unfolding as global conditions allow. This research opens up exciting possibilities about the prevalence of intelligent life in the universe. If intelligence emerges naturally when planetary conditions are right, rather than through an improbable series of accidents, we might not be as alone in the cosmos as we once thought. Next, an update from the mission that just keeps on giving. In a remarkable scientific achievement, NASA's OSIRIS-REx mission has revealed groundbreaking discoveries from its sample collection of asteroid Bennu. The mission, which successfully returned approximately 120 grams of pristine asteroid material to Earth last September, is providing unprecedented insights into the early solar system. Analysis of the samples has yielded an extraordinary finding: the presence of tiny crystals of salt minerals, specifically halite and sylvite. This discovery is particularly significant because halite is extremely rare in meteorites, having been found in only 3 out of hundreds of thousands of known specimens on Earth. The presence of these salt minerals suggests that water activity may have once existed on Bennu's parent body. The research team has also identified various other salt minerals, including sodium carbonates, phosphates, sulfates, and fluorides. These minerals typically form through the evaporation of brines, similar to the deposits we see in Earth's salt lakes. This discovery provides compelling evidence of ancient water activity in the earliest days of our solar system. But perhaps even more intriguing is what these salt minerals mean for the potential development of life's building blocks. On Earth, these minerals act as catalysts for forming organic compounds such as nucleobases and nucleosides, the fundamental components of biological systems. Indeed, further analysis of the Bennu samples revealed a diverse array of organic compounds, including 14 of the 20 amino acids found in Earth's biological processes, as well as all 5 nucleobases present in RNA and DNA. While this doesn't indicate the presence of life on Bennu, it does suggest that the asteroid's parent body once provided an environment conducive to assembling life's essential components. These findings could have significant implications for our understanding of similar environments elsewhere in the solar system, particularly on bodies like Saturn's moon Enceladus and the dwarf planet Ceres, both of which are known to have subsurface brine oceans. This pristine sample from Bennu continues to offer new insights as researchers delve deeper into its analysis, potentially reshaping our understanding of the early solar system and the distribution of life's building blocks throughout space. Let's turn our attention to some fascinating new findings about Earth's inner core that are challenging our previous understanding of our planet's deepest layer. Recent research has revealed that the inner core, long thought to be a solid sphere of iron and nickel, is actually far less rigid than scientists previously believed. Deep beneath our feet, nearly 3,000 miles below the surface, scientists have detected unexpected structural changes in the inner core's near surface. This discovery comes from analyzing seismic waves from 121 repeating earthquakes near the South Sandwich Islands over a period spanning from 1991 to 2024. What makes this particularly interesting is how it appears to interact with the outer core, that swirling layer of liquid metal that surrounds it. The turbulent motion of the outer core seems to be capable of actually deforming the inner core, something we hadn't observed happening on human timescales before. These findings have significant implications for our understanding of Earth's magnetic field, which acts as our planet's protective shield against harmful solar radiation. The interaction between the inner and outer core plays a crucial role in generating and maintaining this magnetic field. If the inner core is more malleable than we thought, it could help explain observed variations in the field's strength and stability over time. The research also supports previous observations, suggesting that the inner core's rotation isn't constant. Some models indicate it may have slowed or even reversed direction around 2010, which aligns with observed changes in seismic wave patterns. This could potentially influence subtle changes in Earth's rotation and even the length of our days. This new understanding of our planet's core is forcing us to reconsider how Earth's internal engine works, and opens up exciting new questions about the dynamic processes occurring deep within our planet. In our final science story today, we're looking at an innovative new approach to exploring low-gravity environments like asteroids and other celestial bodies. Researchers at UCLA's Robotics and Mechanisms Laboratory have developed a fascinating new robot system called Splitter. That's the Space and Planetary Limbed Intelligent Tether Technology Exploration Robot. What makes Splitter unique is its design. Imagine 2 small, 4-legged robots connected by a tether, working together like a high-tech version of the game Bola. But don't let this simple description fool you. The system employs sophisticated control mechanisms that allow it to move with remarkable stability, even in airless environments. The team chose a jumping locomotion method rather than traditional wheeled rovers because it's much more effective for navigating the jagged, uneven terrain found on asteroids. And unlike flying robots, it doesn't need an atmosphere to operate. Each robot weighs just about 10 kilograms on Earth, making them even more agile in low-gravity environments. What's particularly clever about Splitter is how it maintains control during movement. The system uses something called inertial morphing, where the robots adjust their leg configurations and tether length to stabilize their motion. This is managed through a sophisticated predictive control system that can calculate exactly how to position each component for optimal stability. The robots can even work together for tasks like exploring cave systems, with one robot anchoring itself while the other rappels down using their connecting tether. While Splitter currently exists mainly as a computer model, it represents an exciting new direction in space exploration technology that could one day help us investigate some of the most challenging environments in our solar system. Well, that brings us to the end of another fascinating episode of Astronomy Daily. From Webb's groundbreaking discoveries beyond Neptune to innovative space exploration robots, we've covered quite a journey through space science today. If you'd like to stay up to date with all these incredible developments in space and astronomy, I encourage you to visit our website at astronomydaily.io. There you'll find our constantly updating newsfeed and can listen to all our previous episodes. You can also connect with us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Tumblr, and TikTok. We love hearing from our listeners and sharing the latest space discoveries with our growing community. To make sure you never miss an episode, subscribe to Astronomy Daily on your favorite podcast platform. You'll find us on Spotify, Apple Podcasts, YouTube, iHeartRadio, or wherever you get your podcasts. This is Anna. Thank you for joining me today on Astronomy Daily. Keep looking up, and I'll see you again next week for more amazing stories from the cosmos.